Hi friends, welcome back to Edupedia World. The previous lecture we started discussing about sound waves and we saw a few of the fundamental concepts of it. Today we will dive deeper and understand the idea about reflection of sound waves. Then we will see an example of reflection of sound wave which is known as echo. The conditions of echo we will see in details and how that can be used to find the velocity of sound. Then we'll see some classic examples where echo is used in real life by humans and animal world alike. So let us see. Similar to the reflection of light, sound also shows property of reflection. Sound follows all the laws of reflection, and the only constraint during reflection of sound is that the thing from which sound is reflected should be sufficiently large that it is larger than the wavelength of the sound. In fact, even for light this condition existed, but we did not have to worry about that because the wavelength of light was very small. But the sound wavelength ranges from 10⁻⁻² meters to 10-meter range. Therefore, obviously the object from which the sound is reflected back has to be pretty large, and that condition needs to be taken care of because there can be objects which are smaller than the wavelength of the sound. So reflection follows laws of reflection. Laws of reflection similar to light, and as I said, the object from which reflection takes place should be sufficiently large. Now an interesting result of reflection of sound is what is known as echo. You all must have heard the word echo, and I guess a lot of you might be knowing what echo is. But to give a formal definition of echo, echo is basically a sound heard after the reflection of sound from a certain surface, from a distant obstacle, after the actual sound has ceased. So it is sound heard by reflection from a distant object after the original sound has stopped. So the point to note here is that echo is a result of the reflection. Second, it is caused by the original sound but can be heard only after the original sound is has stopped. We will talk about that. Why is it so? And then it should be from a distant object. We will also talk about that. So to begin with, you need to know that the human ear can distinguish two sounds only when they are separated at a minimum of 0.1 second. So if two sounds come within 0.1 second gap, less than 0.1 second gap, then the human ear cannot distinguish it. So in order to hear the echo, there should be a time gap of more than 0.1 second between the original sound and the reflected echo sound for the echo to be heard, right? Therefore, condition is more than 0.1 second gap between original and reflected sound. Now what does this mean? What is the consequence of the 0.1 second gap of between the original and reflected sound? The consequence is that the surface from which reflection takes place need to be at some minimum distance so that the echoed sound gets 0.1 second time for itself. So let us try to see what that minimum distance should be for the echo to be heard. Suppose here is a source and this is my surface on which reflection is taking place. Let this be the distance minimum. Let me write Tm. So distance minimum for the echo to be heard. Okay, so you can see that the sound will start from here and it travels all the way till here and travels back here, right? So basically the sound will have to travel 2 dm. So total distance, if the surface is dm at a distance dm, then total distance to be traveled is 2 dm, and the minimum time can be 0.1 second. We are taking the boundary condition. So any distance which comes out of this and the distance is more than this dm, then we can hear echo. But if that distance is less than dm, then we will not be able to hear echo. Now we know that the speed of sound is roughly, last lecture I mentioned it is roughly 330 meters, but some places you can also take it as 340 meters per second. Really depends on the temperature and humidity conditions. We'll do the calculation based on 340 meter per second. Now given that the velocity is this much, distance is this much, time is this much, we can write velocity or time is equal to total distance upon the velocity, right? The total distance is, let me write it here, use a different color. Total time is 0.1 second, total distance is 2 dm, and velocity is 340. If we cross multiply it, what we'll get is dm turns out to be 340 times 0.1 upon 2, which is 17 meter. So through this calculation we can see the minimum distance of the obstacle and the observer. This is basically the observer, because the observer is the one who is hearing, right? So this is the observer. The minimum distance between the obstacle and the observer should be 17 meter. Now with this calculation, now we know why the definition of echo has a distant object, because there is a minimum distance to be taken into account. Okay. Next, let us sum up the conditions for a echo to be heard. The first condition is that the minimum distance criteria should be fulfilled. D should be greater than 17 meter. Second condition is that the obstacle should be larger than the wavelength of sound. And third is that the intensity of sound, should be high enough So the intensity should be sufficient initially for the sound to have sufficient amplitude when it sufficient noise when it reaches the observer after reflection. So these are the conditions for a echo to be heard. Okay, now that we have seen these things, we can use the concept of echo to determine the speed of sound. How can we do that? Let me show. Suppose that we know that the distance between two objects, the observer and the surface. Let me draw it out here. Let's say an observer is here and a surface is here. Surface. And we want to measure this distance. Rather, we want to measure the speed of sound, and we know this distance. Let this distance be d. Okay, we know the distance. What we can do is we can time the difference between the original sound and the echoed sound. So we have the time difference, we note as t, the distance traveled by the sound, by the echoed sound, will be 2d, right? Therefore, what we can do, the velocity of sound can be found out to be v, capital V. Velocity of sound is distance upon time, that is 2d, which we know since we know the distance, upon t, that is the time we have timed between the original sound and the echoed sound. Okay, so this simple experiment can help us find the speed of sound. That's exciting. But the point to note here is that you need to be at a minimum distance of 17 meters, else you will not be able to differentiate, as we have already seen. Okay, so this kind of gives you a overall idea about echo, the concept of echo. Next, let us see some of the practical uses where echo is put to use. Echo is put to use in several scenarios, as we will see now. But to begin with, let me point it out that it's better to use ultrasonic sound because of a few properties of ultrasonic sound. Namely, they can travel undeviated through pretty large distance. Second is they can be confined as very narrow beams, so they can be very well directed in a particular direction. And finally, they are not easily absorbed by the medium, so they can as a result travel very large distances. Therefore, let me write it down. Usually ultrasonic sound is used. Now that we know why ultrasonic sound is used, let us see some of the applications it has. One of the prominent applications is in the animal kingdom, where bats use ultrasonic sound and the concept of echo to travel through in the darkness. They have a source of sound, ultrasonic sound, and a receiver in their own body, and they radiate out the sound, and by observing at how much time does the reflected sound come back to them, they estimate at what distance there is an obstacle. That is how bats traverse during night. Similarly, dolphins use the same concept to detect some obstacles or enemy dolphins, not dolphins, rather enemy animals in the water. This is where animal kingdom uses the concept. Now, for human civilization, there is something known as a sonar. Sonar is sound navigation and ranging. What happens in this is, suppose there is a ship in the water and it has both a source and a receiver. What sonar does is that the source will generate sound and it will transmit it in different directions, and whenever an obstacle is encountered, the obstacle will reflect back the sound and the receiver will receive it. Now we will know that the time difference between the emitting of the sound and the receiving of the sound, and as a result depth analysis can be done, that is from how much depth is the sound being reflected back. Similarly, there is a concept parallel to sonar which is known as radar, which is used in the aircraft and the aviation industry a lot. But the only difference is in radar is that they use electromagnetic radiations rather than sonar radiations. Okay. Finally, we have a lot of use of echoing system in the medical usage in order to image. It is basically mainly used in imaging purposes of different organs inside the human body. One of the classic example is ultrasonography. So we see that the concept of echo, if thought out well, can be used in many practical applications. This brings an end to the topic of echo. The next class we will see some numericals based on the concepts we have learned today, finding out the velocity of sound or finding out the distance of an obstacle from the observer, such things. So till our next class, have a great day. Goodbye.